Despite having a sore throat, forum user Farron still pair codes with me and even draws this awesome splash screen for this video. And as it says, Spine Unity can now generate attachments from Unity Sprites. And the briefcase here is pretty significant in that the idea is that even though Unity has its own sprite packer, we should be able to pull sprites out of that packing process and just drop them onto a spine skeleton now while utilizing the packing from Unity. So to demonstrate that, I'm going to pop open Unity and put my foot soldier example on screen. This is normal skin, spawn him into the scene. And he doesn't have any weapons or equipment or anything like that. It's just the base soldier. He does, however, have a slot near his hand in the correct place in the draw order for a weapon. Normally I would do this by pulling in another atlas, using the atlas region attacher or something along those lines, using the standard libgdx or atlas assets. But I wanted to show another way to do this, which could really change a lot of people's workflow in terms of bringing in images arbitrarily without having to repack them in Spine or reattach them through the Spine project, especially if you already know their pivot point for things like equipment and swords, shields, guns, that kind of thing. So the next thing I'm going to do is create a folder called Sprites. It can be named whatever, but keeping things organized. And I've got a folder of various equipment I use with these characters. And I'm actually going to drag the whole folder in. And you'll see they all show up as textures. I'm going to take all of these and turn them into sprites. Hit apply. Now they've got their alpha channel intact. I'm going to uncheck a couple things just because. There's no real requirement to do this, but it does make things look better. And this is generally the same settings as the spine atlases get by default. The next thing I just want to show is that the pivot point of these sprites is respected during the import process now. So I can change them to custom or go to sprite editor and move the pivot point roughly to where the hand bone would attach or where the hand slot would attach. And then apply that to that sword and just walk down the line. Do it to all of them. One more. There we go. Okay, so there is a new component. Let's set up an animation first, why not? Put the idle on. A new component called Sprite Attacher. It's pretty straightforward and it gives a good code example of how to use the new sprite systems. But the general idea is you can take the sprite object, not the texture itself, but the sprite object, and drag it into the sprite slot. Although if you drag the texture, it does work. Just note that it is the sprite reference, not the texture reference, that does this. And then choose the slot that you want it to attach to. So in this case, the weapon slot. And when we hit the play button, you should get a sword. Uh-oh. It says sprite is not packed. Which means we need to pack this into a sprite sheet before we can use it. So to do that, I'm going to take all of these and give them a packing tag and call it equipment and hit apply. So now when we check out the sprite packer window, in Unity 4 this does require Pro, however in Unity 5 is a free feature. So if you're a Unity 4 Pro user, fantastic. If not, good luck. Okay, so now these are all packed into the same background sprite atlas. When we hit play, now we have a sword on our character. You'll notice in the draw call list there are the two original FS white materials and then the Unity packed sprite material, which is generated at runtime only because the texture atlases don't exist until you hit the play button. And has a reference to the Unity generated atlas. So this wasn't generated by libgdx, it was generated at build time by Unity by figuring out what sprites were atlased with which tag. So there you go, there's the rudimentary attach from Unity Sprites. So if you made any changes to these or brought in new ones, just add them to the packing tag and you can pull them in from here. No need to re-atlas file the GDX or anything like that. Obviously there's a draw call count hit when you do this, but if you've got 150 objects you need to swap in and out, sometimes this is just easier, as long as you can spare the performance anyway. Moving on, I wanted to show a scripting demo for some of the new features included with this and how to do this with code instead of just using the Sprite attacher script. So I'm going to call this Sprite example and remove the Sprite attacher and open that up in Visual Studio. There we go. Okay. So step one, we need to get a reference to skeleton renderer. There we go. Now what do we want to do to skeleton renderer? We definitely want to do something with sprites, so I'm going to have a sprite object that I can reference, and let's see, do a few things. Let's say public string slot, and we can call this a spine slot so we can get an easy selection of it. Now we should be able to use skeleton renderer, thanks IntelliSense, dot skeleton dot attach Unity Sprite, and then just give it a direct reference to the slot name and the sprite. And if you want to, you can specify a shader here as well. If in case you don't want it to use the standard spine skeleton shader, you can use the spine skeleton lit one or any of the other custom ones floating around. And we're done. As soon as we start this up, we'll have a Unity Sprite that becomes in a region attachment and gets attached to this slot. This also returns the attachment itself. So if you wanted to do anything else or cache it somewhere, maybe change its color independently, this is a good way to get that variable stored somewhere. Let's see what that looks like in the inspector. You can give it a sprite. Let's pick the different weapon. Hero weapon, why not? And choose the weapon slot. Hit play. Bam, done. So in really one significant line of code, you can now attach sprites directly to a spine skeleton. The next thing I want to show is adding a sprite as an attachment to a skin. So I'm going to create a spine skin variable, and instead of adding it to the skeleton itself, I'm going to add it to the skeleton data, which means all instances of this skeleton will now have access to a reference to this, and then you can access the attachment with set attachment and then give it the slot name. Let's see, slot and sprite.name, something like that. But to generate it, the first thing we need to do is tell skeleton renderer to give us a skeleton data, the skeleton data itself. You can also get this with skeleton data asset and then get skeleton data, but since we already have a skeleton, we might as well just use the data field. And then choose add Unity Sprite. In this case, we want to give it the slot name, a reference to the sprite, and then the skin name that we want to attach it to. If you leave this as blank or quote quote, it will give you the default skin if you don't actually have any skins on your character. In this case, I'm just going to give it the skin because I already specified a skin drop down here, and we don't need a shader. So this will add an attachment, and also it will, provide a reference back to it. But now that it's added to the skin itself, we should be able to choose set attachment with the regular set attachment function for the current given skin rather than having to directly reference the attachment. So now, changes a little bit. I know for a fact this is the white skin and it's the white armor set. So I'm going to choose the white skin here rather than the default one, which would be nowhere, which would also cause set attachment to fail. So now when I hit play, we should have, there you go. And notice that even though we're at runtime, we should now also see the weapon hero attachment in the inspector for the skeleton data, as well as showing up inside of skeleton utilities slot list under the weapon slot. This will not work outside of runtime because the atlas that is generated by Unity does not exist outside of runtime. It is a runtime only thing, which means this is not fully interchangeable with the spine atlases, but it's pretty close and pretty useful for dealing with loading assets at runtime, especially if you want to constantly be adding new things and not worrying about repacking them. Let's see, are there any other functions? I think I added one more thing, the skeleton extension. What did we add? Oh yeah, 2 region attachment. Did we already go over that? I think we did. No, we didn't. There's one more way to generate an attachment. And I want to go over that too. Can clear all of this stuff out. Like that. And make a spine dot region, and actually don't need region attachment, we'll just do attachments. Say attachments equals new attachment array of Sprite's length. So if you want to pre-generate a list of objects that you want to attach, let's say at a press of a button or in an inventory or something along those lines, it's pretty straightforward to do this now. So we can actually just do attachments I equals sprites I dot to region attachment, and again you can specify a shader if you want, but this will take the sprite itself and generate an attachment out of it, and now you can just apply these directly to your skeleton renderer or add them to a skin or whatever else you may want to do with it. Let's see. That pretty much covers all of the examples. I do want to go over some of the technical elements of how this is magically happening in the background real quick. I tried to leave some comments in here, but inside of the sprite attacher script there is also a sprite attachment loader class that implements the attachment loader interface. There's definitely some stuff left to do, in particular with memory cleanup. There's not really a clean way to know when you're done with the atlas. So I'm kind of leaving that up to you guys to figure out when you need to dump it. In general, though, the atlas table should be cleared of anything that you're not using if you actually have a memory footprint problem. The pre-multiplied atlas IDs list should not be cleared, and I'll go over that in a moment. The constructor for sprite attachment loader should look pretty familiar to the material attachment loader that is part of the atlas asset script. The tight packing mode is not supported, and each sprite attachment loader at the moment is only capable of loading a single sprite per instance of the sprite attachment loader. I may refactor that a little bit later, but for now, bear with it. That's really the only way to use it safely at the moment. Okay, so during the construction process of a sprite attachment loader, and you can see some of the Unity extensions down here, as in the to-region attachment. It shows generating the new loader with a reference to Sprite and a shader, a direct reference to a shader, and then generating an attachment using loader new region attachment function, then nulling out the loader because we don't need it anymore. So there's one major problem with the the Unity texture packer, and that is that it does not understand pre-multiplied alpha, and it has a lot of problems dealing with that kind of thing. Even if you use targas instead of PNGs and pre-multiply the alpha yourself instead of worrying about compression, the texture packer will still break certain images, and you will end up with digital garbage all over your texture once it starts being rendered by the spine skeleton shader. So to get around that, I keep a list of textures that have already been put through the Sprite attachment loader once, and upon loading, the first thing it tries to do is check to see if I've already processed this image at any point during the runtime process, or at any time since the texture has been loaded from disk. And it will pre-multiply it and alter the original source texture in memory. So this won't edit something on disk, it will only alter the one that is currently in memory. In order to do this, it must be a readable texture, which means if you don't want to use one that's part of a packed list, then you need to make sure the texture itself is readable. But the general idea is it simply applies a pre-multiplied alpha effect to it so that it removes all the digital garbage that's generated by the Unity texture packer. The new region attachment function is pretty straightforward, a little complicated, but it's easy to read. You just generate an attachment based on the original texture. The one weird thing about this is that it doesn't generate one atlas region per attachment, as if you would have with the spine atlases. It uses one atlas region per Unity packed texture. And the reason for that is that the Unity Sprite data structure already contains all the information to regenerate the attachment. I didn't see a reason to duplicate that kind of data. In addition to that, it also caches I guess they're called faux atlas regions, because they're not really atlas regions, they're just containers that make it easier for the skeleton renderer to pick apart this information and render it correctly. So in general, you will only have one material for every page of Unity packed atlas, which is pretty much the same way that the spine atlases work. So there's a very close analog there, which is why it ties in so nicely with skeleton renderer. Let's see. I have not actually been able to test the rotated function. I have not been able to get Unity to generate an atlas with rotated parts on it yet. But when I do, or if someone does, please send me something that I can reproduce, and I will definitely make sure that's working, if it's broken. That's pretty much it. The rest of the stuff in there is pretty straightforward. It does respect the pivot position by calculating with bounds. I'm aware that Unity 5 actually exposed the .pivot property, but it doesn't matter. This works just as well. New mesh attachment is probably the only other one of these that I will implement eventually. It should be possible to do this in Unity 5 by getting the vertex list of a packed sprite, if it was packed in tight mode. If not, it'll be processed as a region attachment anyway, but I can't do this in Unity 4, so I didn't bother implementing it yet. New skin mesh attachment, a new bounding box attachment, meh. I don't really see much of the point. Anyway, there you go. Thank you again, Farron, for awesome imagery and pair coding with me this evening. See ya.